Hello everyone, I'm Shruti. Today I'm going to talk about float which are solar panels installed on water bodies. In this talk, I'll explain how they work, the recent advances up to 2025, real world examples, and future outlook. What are float voltaics? Float voltaics or floating solar farms are just like normal solar panels, but instead of being on land, they are placed on lakes, reservoirs, and canals. They are supported by floating platforms, which saves land space, reduces water evaporation, and keeps the panels cooler. How they work? These systems have solar panels fixed on floating pontoons. Cables connect the panels to inverters, which convert electricity into usable power for the grid. Anchors and ropes keep everything stable even if water levels rise or fall. Maintenance walkways allows engineers to inspect the system safely. And the benefits and challenges. Benefits include more efficiency since water cools the panels, land is saved for farming or housing, and evaporation from reservoirs is reduced. But there are challenges higher cost compared to land solar, corrosion from water, biofueling from algae, and risks from waves and storms. The recent advances up to 2025, many advances have been made. We now use stronger and UV resistant materials for floats. Some floating systems even follow the sun to increase output. Offshore floating solar is being tested in seas. International safety standards are also improving. Environmental and sustainability impacts. Float voltaics help reduce water evaporation and sometimes cool the water's surface. However, shading may affect fish and aquatic plants. That's why projects usually cover only part of water body and monitor water quality closely to avoid harm. Mooring and anchoring strategies. To stop the panels from drifting, engineers use mooring systems. They can anchor panels to the shore, to the bottom of the lake, or use flexible ropes that move with waves. Choosing the light, choosing the right type depends on depth, wind, and water movement. The real world examples and projects. Some big projects include Singapore's Tengeh Reservoir, a 60 megawatt plant, India's 100 megawatt Ramagundam floating solar, Indonesia's Sirata project, the largest in Southeast Asia, Portugal's Alqueva hybrid project combining hydro and solar, and in 2025, France launched Europe's largest floating solar plant. These projects prove the technology is really growing. Hybrid and co-located configurations. Often, floating solar is combined with other energy systems. For example, FPV on hydropower dams shares the same grid. Offshore FPV can be placed near wind turbines. Some projects even install solar over canals, which saves water and generates clean energy. The environmental and regulatory considerations. Floating solar usually performs slightly better than land solar because panels stay cooler, but predicting exact energy is harder. Waves, water reflection, dust, and tilt all affect output. That's why new computer models are being built to improving accuracy. Coming to the future outlook and challenges. In the future, we will see floating solar move into the oceans, better materials, and smart maintenance using drones and robots. Floating solar might also be combined with fish farming, desalination, and hydrogen production. With all these advances, float voltaics are becoming a key part of clean energy. Yeah, thank you for watching. This was an overview of float voltaics, solar energy on water bodies. It is an exciting technology that combines renewable energy with smart use of space and water resources. Thank you.